Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the TG set Telangana State Entrance Test 2024. In this video, we discuss the solution of a problem from the solutions of two problems from linear algebra. They are placed at serial number 67 and 68. These are two simple problems on dimension of subspaces. These two problems are suitable for all these examinations. Right. We take up the first question, question number 67. It is on the dimension of the null space. Right. If a 7 by 5 matrix, capital A, has rank 2, then the dimension of the null space of A is, we are given four options. Right. Let's now discuss the solution of the problem in detail. We are given a 7 by 5 matrix named as capital A, and the rank of A is given to be 2. Note that the number of the columns of this matrix is 5. That is required, that information is required for us. Now, required to find the dimension of the null space of A. It is denoted, the null space of A is denoted by n of A, and we have to find out the dimension of null space of A. The dimension of null space of A is the nullity of the matrix A. It is also called the nullity of the matrix A. Once we have the rank and nullity, we remember the famous Rank-Nullity Theorem. It says, for any matrix A, the rank of A plus nullity of A is equal to the number of columns of A. Here, the rank of A is 2. We want to find nullity of A. The number of the columns of A is 5. So, it will be 5 minus 2, that is 3. The nullity of A is 3. That is, option 3 is the answer for this question. Now, the rank of A is 2 plus nullity of A, which we want to find, is equal to the number of columns of A, and that is equal to 2 plus nullity of A. The number of the columns of A is 5. Therefore, the nullity of A is 5 minus 2 is equal to 3. That is the dimension of the null space of A, that is equal to 3. So, the answer is 3 appearing against option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of a problem from the section linear algebra, which is related to the dimension of the null space. Right. And this is a very simple and straightforward question. Don't expect such questions always. Once in a while, such questions do occur. Not always. We move on to the next question. That is question number 68. It is related to the dimension of the subspace. The given question is the dimension of the subspace, capital W, of R power 4 spanned by the vectors. The first vector, the 4 tuple, 1, minus 4, minus 2, 1. Second vector, 1, minus 3, minus 1, 2. The third vector, 3, minus 8, minus 2, 7. Is, we are given four options. We have to find the dimension of the subspace spanned by these three vectors. Let's now discuss the solution of the problem in detail. We have the vector space r power 4 over r. We are given the subspace W of r power 4 spanned by the above 3 vectors. These are the 3 vectors. Right. We form, that is, the W is spanned by the linear span of these 3 vectors. Right. We want to find the dimension of W. Right. Let's now write the vectors of W as the rows of the matrix A. So this is the matrix A. So on this, we want to reduce this matrix into a row-reduced echelon form. For that, we make elementary transformations. The first elementary transformation is R2 is R2 minus R1, so that the element in the second row first column element becomes 0. And R3 is R3 minus 3R1, and thereby this element in the third row first column will become 0, and it is equivalent to after the elementary transformations. So this is the one. So you get this, and we observe that 0, 4, 4, 4, the third column, is a multiple of the second column. So make a elementary row transformation again. R3 is R3 minus 4 times R2. Then it is equivalent to this matrix. So the first row is 1 minus 4 minus 2, 1, 0, 1, 1, 1. So the rank of this matrix, this is a row reduced echelon form. The rank of this matrix is the number of non-zero rows in the row reduced echelon form, that is 2. And straight away you say the dimension of the subspace generated by these 3 vectors is 2. The answer appears against option 4. Our answer is option 4. Anyway, and now the W is spanned by not these 3 vectors but these 2 vectors. What are these 2 vectors? They are the rows of this row reduced echelon form. And note that they are linearly independent. Why? One is not the multiple of the other. And not only that, they are in a row reduced echelon form. The rows are linearly independent. Right. They are linearly independent. And so the set consisting of these 2 vectors will be a basis for W. And the dimension will be the number of elements present in the basis, that will be 2. So note that these vectors in W are linearly independent. So the set consisting of these 2 vectors is a basis of W. Therefore, the dimension of W is the number of elements present in this basis, that is 2. So the dimension of W, that is the dimension of the subspace W generated by these 3 vectors is 2. The answer appears against option 4. The answer to this question is option 4. That is the detailed discussion of this simple question. And that is why I call these 2 questions as simple questions. And I am sure that you have liked these 2 questions. And I make an alert that don't expect such simple questions always. Once in a while, sometimes you get, sometimes you may not get at all. But anyway, you must be prepared for the worst. And good questions, difficult questions do occur, and you must prepare for that. Right. I am sure that you have understood the solution of these 2 problems. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I'm sure we will be meeting once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.